In this second video, or second part of multinomial distributions, we are going to do a test for independence, and that's the independence between two categorical variables. We could find a lot of situations where we are interested in whether or not there's a relationship between two variables, such as age and preference for type of entertainment, whether gender and perhaps gender and maybe extracurricular activity. There's some kind of relationship between those. Salary and gender, is there some kind of relationship between those as well? So test for independence is really about testing the independence between two categorical variables. All right, so let's take a look at this problem that we have, and we are looking at hiring and firing plans at private and public companies. A Deloitte employment survey asked a sample of human resource executives how their company planned to change its workforce over the next 12 years. A categorical response variable showed three options that either they are going to, so those three options are as follows. The company plans to hire and add to the number of employees. The company plans no change, or the company actually might be planning layoffs and reducing the number of employees. Another categorical variable indicated if the company was private or public. So we have those two companies, and then we want to, not two types of companies, that is, see if there's a relationship between those two. So conduct a test of independence to determine if the employment plan for the next 12 months is independent of the type of company. So in this case, we have a small problem, which is a 2 by 3 problem. If we wanted to, we could say, all right, let's do a confidence interval for the difference between the proportion of private companies versus public companies that plans on employing more people. If we find a significant difference, then there should be a difference between, or some kind of relationship between company and the employment, the plan around employment. Okay, so with the test for independence, let's see how we frame that. In terms of our hypotheses, HO, HA. So type of company and employment plan are independent. Type of company and and employment plan are independent versus type of company and the type of company and an employment plan are related. So HO, HA, if there's no relationship, then PIJ is equal to PI times PJ, where PI is the row probability and PJ is the column probability. Pij now is not equal to Pi times Pj. That relationship, when it comes to independence, really comes from basic probability theory. When we have two events that are independent, say for example A and B, if A and B are independent, so we have independent events A and B, we know that PA and B, the intersection of those two, is the probability of PA times the probability of PB. So that's much the same thing. Here we're talking about I and J, so PI times PJ. All right? So it's the same basic concept. However, if they are dependent, that rule does not hold. Okay, so that's the test statistic. Sorry, not test statistic, the hypotheses. Let's do the test statistic. One of the nice things about this sort of problem is that the test statistic is not changing at all. Oh, the thing is acting kind of funny tonight. Well, I'll do step 2. Test statistic is the same one, which is chi-squared f minus e over e squared, and then we add it all up. All right, you know that there's an ij in there. I sometimes leave it out, but as long as you know it's fij minus eij squared over eij. So that's a test statistic. Decision rule. Would be, we have to just if chi-squared is greater than or equal to chi-squared critical, reject HO. Well, what are we being asked? Alpha is 0.05, and we need the degrees of freedom, which is row minus 1 times column minus 1. So for this problem, we just have two categories of companies. So this really is equal to 3 minus 1 times 2 minus 1 is equal to 2. So our critical value, chi-squared critical, is just chi-squared 0.052, which I believe, if I'm not mistaken, is 5.99. All right. Let me just verify that so I don't give you something in error as the critical value. Just going to look through my notes here. So let's double check that. I'm going to go to the chi-squared table. So we have, why did that happen? I already had it. Shouldn't have had to go back all over again. But anyway, it's making me work a little bit. Let's do that. So we have 2 degrees of freedom, and the area in the tail is 0.05, so it's 5.991. So I had it correct. So if chi-squared is greater than or equal to 5.991, reject the null hypothesis. That's step 3. Step 4 is essentially the same thing we did in the first problem, which is that we need to find the row totals, the column totals, and then find the expected values. Right? So let's do that. So 4, we got to go with the following values. So let's look at the values that we have. We have public and private. Well, let's do it the other way around, because I believe we had here private and public. Private, public. Right? 37, 32. In terms of, let me leave a little more space. Public. 37, 32. All right? And that it has to do with adding employees, add, same, and then layoffs. We had 19 and 34, and then we had 16 and 42. So if we do totals, Our totals are 69, 53, and 58 for a total of 180. And if we add the columns, we would have 72 and 108. Right? So we know that to find the expected frequencies, we simply need row total times column total. So to get this first one right here, we would have to go with row total, column total, divided by grand total. So E11 would be 69 times 72 over 180. Alright, and that gives us 27.6. So I'm just going to write the values at 27.6, and then we have 21.2, we have 23.2. I need a little more space here. So what do we have for the others? We have, when we do the calculations, 41.4. Then we have 31.8. And then we have 34.8. Alright? So that's the expected values. So Fij's are those values. So those are your Fij's, and those are your EIJ's, sorry. EIJ. Alright? Now we have to find the components. When I say the components of chi-squared, because we need to do that for each one of them. I'll just do one. So chi-squared is chi-squared then is, if I do the first one, 37 minus 27.6 squared over 27.6 plus next one, 32 minus 41.4 squared, of course, the 41.4 plus, and the very last one is 42 minus 34.8 squared over 34.8. That gives us a value of 9.44. So if we look at the critical value approach, so step 5, decision, conclusion. So since 9.44 is greater than 5.99, reject HR. And what do we conclude? We conclude that there is sufficient evidence of a relationship between the type of company and its employment plan. There is sufficient evidence of a relationship between type of company and employment plan. Alright? Possibility of type 1 error. If we wanted the p-value, then we have to do the following. P-value is the probability of chi-squared greater than or equal to 9.44. We look under 2 degrees of freedom. Let's see what we got. So 2 degrees of freedom, looking for 9.44. It's between 0.01 and 0.005. So we could say that the p-value is greater than 0.005 but less than 0.01. All right, and that gives us our p-value. Actually, it turns out to be 0.0089 if you use Excel. Right? Good. Let's see if there's another part to this question. That was part A. Discuss any differences in the employment plans for private companies over the next 12 months. Okay, so let's look at that. So to do that, what you're going to have to do is to calculate some sample proportions. All right? And one of the ways to do that is to simply just calculate the proportions for each of the values for each for each type of company. What proportion of those companies are going to add? What proportion of them are going to make no change? What proportion of them are going to actually lay off people? And the way in which you do that is by once you have your totals, and remember we have the totals of if I go back to here, my totals were 72 and 108. So let's look at this page instead. So what I would do is I would actually take 37 over 72. That would give me the proportion of private companies that will add employees, compared to 32 over 108. That would be the percentage of public companies that are going to add employees. And then so if I do that, if I repeat that, I would actually have probabilities under each of those categories. So let's do that. I would do 37 over 72, 19 over 72, and 16 over 72. It should all add up to 100%. 32 over 108, 34 over 108, and 42 over 108. So that's kind of what I want to do with this right here. So we'd have private, we have public, and then here's what we would find. So add, same, layoff. So it turns out the proportions are 0.51, 0.26, and 0.23. All right. Over here it is 0.30. I'm rounding to two decimal places. 0.32, and then this is 0.38. Actually, this should be 0.39. This value should be 0.31. Okay, so it adds up 100%. Okay, so let's do a comparison. If you look at these values right there, so when we look at the values, we could see that private companies are more willing to be adding employees compared to public companies. All right, so you can see 0.51 versus that, and then you see that a higher percentage of public firms are doing layoffs compared to 0.23 over here. So we would just make a note of those in our general comments, saying that clearly private firms are more likely to hire, and public firms are more likely to lay off people. Okay? And that shows also some evidence of a difference between these two categories, private firms and public firms, with respect to the employment plan. All right. So that brings us to the end of an example where we're testing for independence. In the first part, we just tested whether or not there's a relationship between the type of company and the employment plan. And then by doing an analysis of the probabilities, we could actually make some, general comments, such as 51% of private firms compared to 30% of public firms are planning on adding people. 23% of private firms compared to 39% of public firms are planning on laying off people. So we begin to see a difference between the two types of firms. All right. So that brings us to the end of our second video on test of independence between two categorical variables. Thank you.